Hello, geometry students. In this lesson, we're going to discuss conditions that would guarantee when a quadrilateral is a parallelogram. So let's start by reviewing from our last lesson properties that parallelograms have. So if you have a quadrilateral that you know is a parallelogram, then you know that the following is true. First of all, you know that opposite sides are parallel. Let's see, opposite sides are parallel, and that comes from the definition of a parallelogram. Okay, secondly, you've proved that opposite sides are also, not only are they parallel, but opposite sides are also congruent. Okay, in addition, we've proved that opposite angles are congruent, and also that consecutive angles are not necessarily congruent. They might be congruent, but they are necessarily supplementary. So that's another thing we've proved about every parallelogram. And then we've also proved that in a parallelogram, diagonals always bisect each other. So those are the properties that we know are true if we have a quadrilateral that we know is a parallelogram. So what we're going to do today is we're going to look at the flip side, and we're going to determine some theorems that determine or that guarantee when a quadrilateral would necessarily be a parallelogram. So imagine, if you would, that you were a quadrilateral, okay? So imagine you're a quadrilateral and you wanted to be a parallelogram. It's almost like you were a quadrilateral and you wanted to earn this parallelogram trophy. So you would be guaranteed to be a parallelogram, and you would earn a trophy if you met any of these characteristics. So let's take a look at several characteristics that would guarantee that any quadrilateral is a parallelogram. So first, if we have a quadrilateral that satisfies the definitions, in other words, if both pairs of opposite sides are parallel. So on this diagram, go ahead and indicate both pairs of opposite sides parallel, and so that's enough to guarantee that we are that this quadrilateral is a parallelogram because it satisfies the definition of a parallelogram. Okay. Secondly, if we have a quadrilateral where the diagonals bisect each other, that is enough to guarantee that that quadrilateral is a parallelogram. So if you would, on this diagram, go ahead and draw the diagonals, and let's indicate with tick marks that those diagonals are bisecting each other. And if that's the case, a quadrilateral or the diagonals bisect each other, that's enough to guarantee that that quadrilateral is a parallelogram. Okay. Next, if both pairs of opposite angles are congruent, then that would be enough to guarantee that that quadrilateral is a parallelogram. So on this diagram, go ahead and indicate both pairs with arcs that both pairs of opposite sides are congruent, and that would be enough to guarantee a parallelogram. Next, if both pairs of opposite sides are congruent, okay, if you have a quadrilateral and both pairs of opposite sides are congruent, that would be enough to guarantee that that quadrilateral is a parallelogram. And then last but not least, if just one pair of opposite sides are both parallel and congruent. We will later in this lesson, we will prove if we have one pair of sides that's both parallel and congruent, that's going to be enough to guarantee that that quadrilateral is a parallelogram. So now let's take a look at some examples of some quadrilaterals, and we're going to determine whether or not the conditions are met to guarantee that that quadrilateral is a parallelogram. In other words, if it would earn a trophy. So we're going to look at what's marked on these diagrams, and you should be able to justify from one of the statements on the other side of your notes if these quadrilaterals are parallelograms. So let's take a look at this first example. We have a quadrilateral where we have one pair of opposite sides that is both parallel and congruent. So we have a theorem that backs that up, so we can say, yes, this is a parallelogram. In the second example, we have one pair of opposite angles marked congruent, but we don't have any idea whether or not these other pair of opposite angles are congruent. So that would not be enough to guarantee that this is a parallelogram. So no trophy for that one. We'd have to say no. In the next example, I see one pair of opposite sides parallel and the other pair of opposite sides congruent. Again, that doesn't meet any of those conditions on the other side of these notes. So we would have to say no, that is not guaranteed to be a parallelogram. It might be, but we're not sure. In example number 4, though, you can clearly see that the diagonals are marked congruent. So that's enough to guarantee that we have a parallelogram, so we're going to say yes to that one, okay? In the next example, I see that both pairs of opposite angles are marked congruent, so that's enough to guarantee that that parallelogram, or excuse me, that quadrilateral is a parallelogram. It would get a trophy. And then on this next one, we have not opposite sides congruent, but we have consecutive sides congruent. We'll learn later in this unit that that's the definition of what we call a kite. This is not a parallelogram, so it does not guarantee that we have a parallelogram. So we're going to now end these notes with a proof. We're going to prove one of those conditions that guarantees when a quadrilateral is a parallelogram. So given this quadrilateral JKLM, we're going to assume that KL and JM are parallel. So let's go ahead and mark that since we're assuming it to be true, okay? We're also going to assume that segment KL and segment MJ are congruent. So go ahead and mark those. So given we have one pair of opposite sides, both parallel and congruent, let's prove that JKLM is a parallelogram, okay? So to do that, we're actually going to do it by using congruent triangles for our, and we'll create those congruent triangles by first drawing a segment. Let's go ahead and draw segment JL and create two triangles. So that's going to be the first step of our proof. We're going to draw a segment JL, and the reason what backs that up is one of our very first postulates of the year that says anytime we have 2 points, that guarantees the existence of exactly one line, okay? So drawing that segment now creates two triangles. Now, what we're going to do is we're going to get these two triangles congruent to each other. And to get them congruent to each other, well, let me do this. Let me go ahead and I'm going to highlight one of the triangles yellow, and I'll leave the other one white. So we're going to get the yellow triangle congruent to the white triangle. So let's start with the fact that those two triangles share a side. So let's say that segment JL is congruent to itself, okay? You'll recall from last semester that that's the reflexive property of congruence, guarantees that every segment is congruent to itself, okay? And then now so I guess we can go ahead and let's mark that segment congruent to itself, okay? So now what we're going to do is we're going to get some angles congruent. Remember, we have parallel lines and a transversal, so that's going to give us some alternate interior angles are congruent. So let's use the given statement that we have a pair of parallel lines. So we're going to say that segment KL is parallel to segment JM, excuse me. KL is congruent to segment JM, and that is given to us, okay? And because of that, that creates we have parallel lines and a transversal, that creates some alternate interior angles that are congruent. So let's go ahead and call this angle 1 and this angle 2. And we can see that we have parallel lines and a transversal, so this pair of alternate interior angles would be congruent. So in step 4, we're going to go ahead and say that angle 1 is congruent to angle 2, because anytime we have parallel lines, that guarantees that, cut by transversal, that guarantees that alternate interior angles are congruent, okay? So if you're keeping track, you might want to put an S right here because we have a pair of sides congruent. Now we have a pair of angles congruent. We only need one more part to get those two triangles congruent. So let's go back to the given and recall that we're also told that KL is congruent to MJ. So let's go ahead and make that statement, that segment KL is congruent to segment MJ. That was given, and it's already marked, so that gives us a second pair of sides congruent. So if you look at the diagram, we have two sides and an included angle of one triangle congruent to two sides and an included angle of another triangle. So that's enough to guarantee that the two triangles are congruent. So we're going to call the yellow triangle JKL. And once we name it JKL, in order for corresponding parts to match up, we need to call the white triangle LMJ. So what justifies those triangles are congruent is that side angle side implies congruent triangles. Okay, so remember what we were trying to prove is that we were trying to prove that JKLM is a parallelogram. So now that we know that the yellow triangle is congruent to the right triangle, we can talk about, how about this angle 3 and this angle 4? That would be J in the yellow triangle and L in the white triangle. So they correspond, and we can say that they are congruent to each other. So we're going to say that angle 3 is congruent to angle 4, and the reason is because of CPCTC, or some of you might want to write definition of congruent triangles. That means the same thing, okay? So now that I know that 3 and 4 are congruent, okay, so if angle 3 is congruent to angle 4, then if we look at this blue transversal and side KJ and side LM that are being transversed by this transversal, then 3 and 4 would be a pair of alternate interior angles. And when those alternate interior angles are congruent, that guarantees that the lines are parallel. So let's go ahead and say that segment KJ is parallel to segment LM, because when alternate interior angles are congruent, that guarantees the existence of parallel lines. So now you can see that we were given that segment KL and JM were parallel. We've just proven that JK and LM are parallel. So we have now satisfied the definition of a parallelogram, and we can say that JKLM is a parallelogram, and we will justify that with the definition of parallelograms. It says a quadrilateral is a parallelogram if and only if its opposite pairs of sides are parallel. Okay, so that's it for our 6.3 notes. So if you have any questions, be sure and ask me in class.